Hey guys, welcome to Technozar. This is Rohit Sharma, and in this video we are going to complete our part 2 of Zener Diode as a voltage regulator. Okay. In part 1 we have seen two designs of Zener Diode. One is when VI is fixed and RL is fixed, and second is when VI is variable and RL, the resistive load, is fixed. In this video we will see about the case 3 and the case 4, in which VI is fixed, the input voltage is fixed and the RL is variable, and and the fourth case will be when the input voltage is variable and also the resistive load is also variable. Okay, on this we will do one question for case 3 and one question for case 4. Okay, so let's start the video. Case 3, when input voltage fixed and RL is variable, the circuit would be like this. When VI is fixed, the resistive load is fixed, and the current through this resistive load, the current through this resistance is also constant, that is fixed. Okay, when RL is variable, then IL, the current flowing through this resistance, will also vary, because I know I is equal to V upon R. If RL is varying, then current will also vary. Okay, that is IL minimum and IL max. If this is varying, then the current through the Zener diode, that is IZ will also vary, IZ minimum and IZ max. Okay, IZ minimum and IZ max. I can say the current flowing through IR is equal to IZ plus IL. Okay, that is the resistance. The current flowing through the resistance is equal to the Zener current plus the load resistance current through the load resistance. Okay, if I have to write the equation, then IR is equal to IZ minimum plus IL max. Okay, first equation. Okay, or we can find the resistive current, the current through the resistance, through this equation also, IZ max plus IL minimum. Okay, now you will say that, sir, we have taken IZ minimum here, but here we have taken IL max, not IL minimum. You know that I is equal to V upon R. Okay, IL. Okay, and when R is minimum, then only IL is maximum, na, because I is inversely proportional to R. Okay, therefore IR is equal to IZ minimum plus IL max. Now we will do one question based upon our case 3. In a voltage regulator shown in the figure, the load current is varying from 100 milliampere to 500 milliampere. Therefore, I can write IL minimum is equal to 100 milliampere and IL max is equal to 500 milliampere. Okay, can vary from this. Assume that Zener diode is ideal. Okay, Zener knee current is negligibly small, and the Zener resistance is 0 in breakdown region. Find the value of R. If they are saying the Zener current is negligibly small, then I can say that IZ minimum is equal to 0. Okay, now from the equation we have seen IR is equal to IZ minimum plus IL max. We have seen this or not? Okay, we have to find the resistance. This is 5 volt. This is 5 volt. If I have to find the current through this resistance, I can write this 12 minus 5 upon the resistance is equal to IZ minimum is 0 plus IL max. IL max is given as 500 milliampere. Okay, I am writing here as 500 milliampere. Okay, now we will solve this for to find the resistance. That is equal to 12 minus 5 upon R is equal to 500 milliampere. Therefore, R is equal to 12 minus 5 is 7 upon 500 milliampere, that is 1000 here. Cancel out 2, 7 into 2 is 14 ohm. 14 ohm will be the resistance. Okay, this is an example based upon case 3 when VI is fixed and RL is variable. Okay, now come to case 4. This is a very important case. So let's see this. When both are variable, when VI is also variable and RL is also variable. When VI is variable, then IR will also be variable and IZ also be variable. When RL is variable, then IL also variable, IL minimum, IL max, and IZ is IZ minimum, IZ max. In this, each and every term, whether it is input voltage, whether it is the current flowing through the resistance, whether it is the Zener current or whether it is the load current, all will vary from minimum to their maximum value. So how can we write the equation? We know that IR is equal to IZ plus IL. Okay, but we have to write this equation in the case of minimum or maximum currents. Okay, if we have to write this, I can write IR minimum is equal to IZ minimum plus IL max. Okay, IL max. Okay, now if we have to find IZ minimum comes here and IR minimum comes to the RHS with a negative sign. Okay, I can write this IR minimum minus IL max. IZ minimum is equal to IR minimum minus IL max. Similarly, for maximum, if we have to find the IR max is equal to IZ max plus IL minimum. From here we can find IZ max is equal to IR max minus IL minimum. So for this case we have to remember these two equations for IZ minimum and IZ max. Okay, you have to remember these equations for case 3 and for case 4. Okay, now we will do one question based upon our case 4. So let's see the question. The question is saying the Zener diode in the regulator circuit shown in figure has a Zener voltage of 5.8 volt. The Zener voltage is given as 5.8 volt, that is the 5.8 volt given here. And Zener knee current is 0.5 milliampere. Okay, they have given knee current is, that is IZ minimum. IZ minimum is given as 0.5 milliampere. We have to find the maximum load current drawn from the circuit, that is we have to find IL max. Okay, ensuring proper functioning over the input voltage, that is 20 to 30 volt, that is VI minimum is equal to 20 volt and VI max is equal to 30 volt. Okay, now we have to find IL max. Okay, now for IL max the equation will be IL max, I can write the equation as IR minimum minus IZ minimum. Okay, is there any problem in this equation? I have written this equation from here. Okay, IL max is equal to IR minimum minus IZ minimum, and IL max, what will be IL max? We have to find this. Okay, IL max is equal to IR minimum. I can calculate from here. IR minimum can be found by 20 minus is the VI minimum, 20 minus 5.8 upon 1 kilo ohm. Okay, this will come out to be, on calculating this will come out to be, this is IR minimum. On calculating this will come as 14.2 milliampere. You can calculate this by your own. Okay, I am writing this here, 14.2 milliampere, and IZ minimum is given as 0.5 milliampere. Okay, on subtracting 14.2 minus 0.5, I will get IL max as 13.7 milliampere is the correct answer. These are some questions which are based upon Zener diode as a voltage regulator. You can practice these questions, and please remember these 4 cases that I have already told to you. This one, case 1, when VI is fixed and RL is fixed, when both voltage, input voltage and the resistive load are fixed. Case 2, when input voltage is variable and the resistive load is fixed. Case 3 is when input voltage is fixed and the resistive load is variable, and the case 4 is when input voltage is variable and resistive load is also variable. Only these 4 cases are present in Zener diode as a voltage regulator. Okay, and these are the questions based upon these 4 cases. Okay, I have taken one question for each case to solve your doubts. Okay, if you have any doubt regarding this Zener diode as a voltage regulator, please follow our Telegram channel, that is ISRO for ECE. Please follow this channel so that you can clear all your doubts. Also, please attend quiz daily at 7 PM through a link provided in the group. And second, if you like the video, please share with your friends as much as possible. And second, don't forget to subscribe the channel. Okay, all the very best.